Welcome everyone, and today we will move to Module 2, first lecture of Module 2, which is Ecological Systems and Resource Limit. But before we move into the Module 2, I thought let us first do a very quick recap of what we have studied so far in Module 1. One of the important things to remember that in Module 2, we move deeper into one of the foundational ideas of ecological economics. And that's something which we have been talking when we discussed in Module 1, that the economy exists within ecological systems and is constrained by ecological limits. So in this module, we try to understand a bit more in detail what are these ecological limits that we are talking about, and also how economy and ecology are interconnected a bit more in detail than what we discussed in first module. Now, before we move to module 2, I think it is important that we need to do a very brief recap of what we actually have discussed so that you can connect the first module with the second module. So as you can see on the screen, we are talking about here some of the classical economists such as Adam Smith, David Ricardo, Thomas Malthus, John Stuart Mill, and and they were primarily actually concerned about production, growth, and markets, right? But interestingly, classical economics did recognize limits to growth, and that is what is the most important thing to remember. That, and in what way, for example, if you remember, Malthus highlighted the tension between population growth and resource scarcity. Ricardo spoke about land scarcity and diminishing return. Then Mill introduced the idea of a steady state economy and emphasized quality of life rather than endless expansion. So it is clear that during the time of classical economics, we did, talk about that economy cannot grow forever. There will be certain constraint which is going to make growth, which will limit the growth. It cannot be limitless growth. However, then we saw that, the rise of neoclassical economics, which we also call this as marginal revolution. So with marginal revolution in the late 19th century, economists shifted towards, profit maximization, utility maximization, and also, market efficiency. And neoclassical economists viewed market, for example, as self-regulatory, technology as capable of overcoming any kind of scarcity or limit, and economic growth as potentially it is as if it is unlimited. And in this whole, context, one thing to remember is that we moved from a macro to a micro lens, in the sense that we started to now talk about more about firms or individuals, utility firms, profit maximization condition, etc. And that is something, if you remember, was also very interesting to recollect, is that there is a saying that the neoclassical economists believe that in the long run, we are all dead. And so the short run was given much more emphasis than long run sustainability. But it is also important how environment was treated in neoclassical economics. And again, if you remember the diagram where economy was considered as a whole and environment becomes a subset of the economy, and where environment was mainly treated as a source of raw material and a sink for waste. And nature itself disappeared from various economic models, such as we discussed about the circular flow model itself. So, but this approach was definitely criticized for ignoring ecological limits, overlooking opportunity cost of growth, in the sense that growth also has a cost. We are not just growing and in void. When we grow, we are encroaching a lot of space which was actually for the natural resource, is something which was not really taken into consideration. It was portrayed that all growth only comes with benefit. There is no such cost associated. And like I mentioned, focusing excessively on short-term efficiency. Now, given these critics, it finally led to the rise of what we call it as an environmental economics, particularly between 1950s to 1980s. And environmental economics actually emerged in response to these rising environmental critiques or environmental problems during this period, 50s to 80s. And it introduced several new concepts such as externalities, market failures, although market failure wasn't new because in public economics there was this whole concept of public goods and market failure. But in environmental economics, they tried to look at this from the environmental goods perspective. Then there was all of the way of internalizing externalities. So the whole concept of pollution taxes and subsidies came in, and various environmental valuation methods such as the cost benefit analysis. The core idea or the core argument of the environmental economics was that environmental problem occurs because environmental costs are not reflected properly in market prices. This was an important development because the environment finally entered into economic analysis. However, ecological economists argued that environmental economics still remained within the neoclassical framework because growth itself was rarely questioned. That whether we can continue growing forever was rarely questioned in environmental economics, and nature was still treated mainly as a market failure problem. So if you can bring nature to the market, then most of your problems can be taken care of, because if you remember, the whole issue was more about social costs and benefits which are not fully reflected in market prices. Now, given this background, we then discussed that all of these also led to absolutely new school of thought, and that is the emergence of ecological economics in 1960s to 80s formally, I would say. So when environmental economics was taking shape, many who did not agree to the way environmental economics was talking about the environment-economy relationship, this led to actually an emergence of this new school of thought. And if you remember, this was mostly influenced by thinkers such as Kenneth Boulding, Nicholas Roegen, Herman Daly, and the central vision was, also fundamentally different. And there was a lot of emphasis also on limits to growth debates during this time. Also different environmental movements happened. So all of these influenced this different fundamental vision. And here the vision was that economy is a subsystem of the finite biosphere. And this itself represents a major paradigm shift. And why so? Because so far we looked at economy as a whole and ecosystem as a part of the larger economy. But now we have reversed that entire way of looking at economy-environment relationship. And we are saying that it's actually other way around. The ecosystem, the environment is the whole, and economy is actually a subsystem of that larger ecosystem. And ecological economists also started to broaden the questions that otherwise in economics we ask. So the questions that came up was like, how large should the economy become relative to ecological systems? Because this kind of died completely, these kind of questions during the neoclassical era. When does growth become uneconomic is something that was also questioned. Can natural capital really be substituted by human-made capital? So if you remember, we discussed about weak and strong sustainability. So the moment you say that human capital can actually replace natural capital, the way ecological economists looks at it, it's like weak sustainability, not strong sustainability, because for them, natural and human capital are not substitutable. They are actually complementary to each other. Now, further, the core concern of ecological economics, what Herman Daly argued, is that ecological economics should focus on three core concerns. The first is the scale concern. The scale asks how large can the economy become relative to ecosystem limits. So that's the scale issue. Then distribution asks how are resources, costs, and benefit shared across society and generation. Allocation asks how efficiently are resources allocated. Now, mainstream economics also focuses mostly but on allocation and efficiency. But ecological economics argues that there is a hierarchy of asking these questions or answering these questions. Scale must come first. distribution second, and allocation is third. Because if economy exceeds ecological limits, even efficient allocation cannot ensure sustainability. So that was the argument. So this slide basically summarizes these major paradigm shift between conventional economics and ecological economics. So conventional economics assumes continuous growth, isolated economic systems, and technological optimism, while ecological economics instead recognizes ecological limits, biophysical constraints, and dependency of economy on ecosystems. So all of these were larger dimensions of ecological economics. So this is simply not, a technical adjustment. It is a completely different worldview regarding the relationship between humans, the economy, and nature. So that's the central takeaway of module 1, is that you cannot actually grow in an infinite way when you are within a finite planet. And it also argues that sustainable development itself needs to integrate ecology, economy, equity, and long-term planetary boundaries. Otherwise, sustainability is not just about sustainability of the economy or just the sustainability of only one part. I mean, it's not just thinking about ecology alone or economy alone or human alone. It has to be something which integrates ecology, economy, equity, and also the ecological limit. Now, before we move to module 2, I just wanted to tell you that this book is a very important or fundamental book for ecological economics. If you have yet not bought it, you can also download this. It's available online. And so far, whatever I am teaching you, if you go through that book, it will become even more clearer. And particularly chapter 1 and 2 is something so far we are looking at. All right. So this is about module 1. This is all that we discussed in module 1, giving a very clear understanding of what is the key paradigm shift. And you have to keep in mind that the key paradigm shift is here on this slide. One of the major shift itself is the recognition of ecological limits, and that economy is embedded in ecosystem, and that, for our economic growth, biophysical limits really, really matter, right? Okay, now let's look at this particular slide, because this slide brings us to module 2, which is ecological systems and resource limit. And, here we move into one of the central ideas of ecological economics that I mentioned, that the economy is not separate from nature, but exists within the ecosystem and is ultimately constrained by ecological limit. So what we try to do here is that the slide basically visually represents the core ecological economics perspective, that economy is a subsystem of the finite biosphere. And unlike the conventional economic thinking, which often treats the economy as an isolated and a self-sustaining system, not connected to anything, but it's just self-sustaining, ecological economics reminds us that all economic activities depends fundamentally on ecological systems for resource, energy, and waste absorption. So therefore, the course is not just economics, right? That is why we say ecological economics. I think this must have become clear to you now, that we connect economy, we do not look at economy as an isolated, self-sustaining system. We believe that economy also has a very strong connect with the ecology. And so if you want your economy to grow well, sustainable, you also need to ensure the relationship between economy and ecology is first understood and then sustained. So if you look at this diagram that you see at the center of the diagram, we see the economy represented as a subsystem here, embedded within the larger biosphere. The economy requires continuous inputs from nature in the form of, energy, raw materials, water, land, ecosystem services. These, inputs support production and consumption activities. However, economic processes, again, when you are converting your inputs through production and consumption into output, the economic process also generate outputs in the form, of services. But along with that, it also bring out waste, pollution, emissions, and heat, which actually again go back to the environment. So therefore you see, first, if you look at the left side of the figure, it highlights some ecological realities. That first, we live on a finite planet with limited resources. Second, economic systems are constrained by physical and thermodynamic laws, which we will pick up today. What does this thermodynamic law has to do with economics? And that this means that resource cannot be actually used indefinitely without consequences, and every economic process involves energy transformation and waste generation. So this is where the concept of entropy comes in. Again, something that we will talk about today in the subsequent slide. But do remember that there is a close connection between physics and thermodynamic limits and the economy. Then there is something like the ecological degradation can become irreversible when environmental thresholds are crossed. So finite planet, limited resources, the physical and thermodynamic limits, and irreversibility and environmental degradation are something that we will touch upon as from the point of view of ecological realities or ecological resources, that they also have certain characteristics. Then if you look at the right side of the diagram, which focuses on resource limits, this includes resource scarcity, production pollution limit, ecological thresholds, and carrying capacity. Now, ecological economics argue that economic growth cannot continue indefinitely if it exceeds these, planetary limits. As society consume more material and energy, pressure on ecosystems would increase, leading to various challenges like we see today, such as climate change, biodiversity losses, resource depletion. Another important aspect shown here is the ecosystem services. The ecological systems remember that it provides a critical life support function, such as climate regulation. That's what you see in the outer sphere, is that climate regulation, water cycling, soil formation, biodiversity, nutrient cycling, and also including waste absorption. These services are essential for both human well-being and economic activity, yet they are often undervalued or ignored in conventional economic analysis. Finally, the slide summarizes some very interesting and important implications of ecological economics. It emphasizes that growth has limits, and not just limits, trade-offs which are unavoidable. There are equity concerns. Sustainability therefore must become central to development thinking. The focus therefore shifts from maximizing GDP alone towards improving long-term human well-being, but within ecological boundaries. So you shouldn't talk about human well-being only and do not even think about that those ecological resources which is going to bring well-being, are they in the right shape or in the right place or not. Now, we had discussed this in our earlier module, but it is important that I bring this concept back so that you can connect it better. And that is what Herman Daly referred to as empty world and full world. Now, earlier economic thinking, do remember, why we call it as an empty world is because at the time when we were talking, when economic thinking developed, we were actually living in a world of abundance. So human population was also relatively small, and environmental impacts were therefore limited. In that context, economic growth seemed almost, costless, because ecosystems were able to absorb waste and provide resources without major, constraints. So therefore, economic growth appeared as if they are costless, as if there is no opportunity cost of growing, because even nature was really, really abandoned. But I think we all would agree that things have changed now. Today, we live in what ecological economists describe as a full world. And that is why it is so important that we need to have this paradigm shift, because we cannot now apply same economic principles which were developed or which were studied at the time when we were living in an empty world. And today we need to understand the full world perspective, right? Today, what we are also witnessing is climate change, biodiversity loss, resource depletion, pollution, and, we have seen ecological thresholds being crossed. This means that as economy continues to expand, the environment and social costs associated with growth also increases. So the key insight is that growth is not always beneficial, or it's not beneficial indefinitely. Maybe it is definitely beneficial in the beginning, but if we do not stop where we need to stop, that growth may actually become something which we discuss is uneconomic growth. And what is that uneconomic growth? When the environment and social costs of additional growth exceeds benefit, meaning costs exceeds benefits of the growth, right? So the perspective fundamentally challenges, therefore, the conventional assumption that more growth would always lead to greater well-being. No, not necessarily. If you keep growing beyond the capacity of the ecosystem to sustain such growth, then the growth, instead of being economic, may become uneconomic, or environmental and social cost of such growth could be very, very high. So opportunity or cost of growth may actually become very high. Now, this brings us to another very interesting concept, because what exactly are we trying to why are we saying that there is a limit to growth, right? So this is one of the most important concepts in ecological economics, and that is the idea of throughput. This concept actually helps us understand that economy is not just the way we look at it as if a monetary system made up of prices, markets, financial transactions. It is also a physical system. The economy is also a physical system that depends continuously on energy and material flows from nature. So if you remember, as I mentioned earlier, there are ecological flows that is happening within the economy, and that ecological flows helps us to, which acts as an input, helps us to convert these inputs into something which is usable, like an outcome or an output, right? So throughout, so basically, what if you really look at the definition of throughput, so throughput basically refers to the flow of energy and material from nature when you first take it as a raw material, through the economy when you convert that raw material into something that you wanted to develop, for example, timber coming in and getting converted into a chair, back to nature as waste, because all of that does not get converted. A lot of waste is also generated during the process of production and consumption. And so finally, that results in waste, emissions, and pollution, which also goes back to nature. And this whole process, the flow of energy and material, you took energy and you took out material, that entire process of flow of energy and material through the economy and back to the nature is something which we call it as a throughput. So the examples are what basically throughput includes: extraction of raw materials, energy use, industrial production, transportation, consumption, waste generation. All of these are throughput. The ecological economics argue that this is extremely important, because economic growth is not only about increasing GDP, income, and market transaction, because every increase in economic activity also requires greater energy and materials, meaning more and more throughput. Therefore, growth inevitably increases material and energy throughput, right? The perspective fundamentally changes how we think about sustainability as well. Conventional economics often focuses on monetary growth, but ecological economics reminds us that all economic systems remain physically dependent on ecosystems and natural resources. So as throughput increases, pressure on ecosystem also increases through resource depletion, pollution, and ecological degradation. And like I mentioned, if that happens, all of that will become much more uneconomic and expensive than the extraction and taking it out as waste would actually become something which becomes difficult for the finite planet to also either to provide as a source or also to act as a sink. So this is very important or essential for understanding why ecological economics argue that infinite economic growth is impossible in a finite planet, because of the flow of energy and material through the economy and back to the nature as waste. Now, this throughput concept is also connected to the law of thermodynamics, which is basically a physics law or physics concept. So the first point to remember is that as I mentioned, that economy is a physical system. This means no economic activity can happen without matter, energy, and ecological support system. And I think this is the fundamental thing. And it is surprising that we never accept it, or we never explicitly talk about it. But none of your economic inputs are not just land, labor, and capital. It is also matter, energy, and several other ecological support system. If you take an example of cotton shirt, if you're a producer who is producing cotton shirt, you need land to grow cotton, you need water for irrigation, you need energy for transportation, you need chemicals for processing, and of course human labor. Similarly, if you are producing a smartphone, it requires metals such as lithium, electricity for manufacturing, and also global transportation systems. And just to let you know, even digital economies depends on physical infrastructure such as data centers, cooling systems, electricity, etc. So, this then connects us to the entropy law associated with Nicholas, who brought the concept of, or I would say thermodynamics principles into economics. Entropy, what is an entropy? Entropy refers to tendency for useful energy and ordered materials to become less useful and more dispersed over time. Right? So, for example, to make it a bit more simpler, what is the meaning of orderly to unorderly, low energy to high energy? For example, you consider burning petrol in a car. Initially, the fuel contains concentrated energy that can power movement. This is low entropy because energy here is organized and it's useful because it's running your car. Once the fuel is burned, it becomes waste heat, exhaust gases, and emissions dispersed into the atmosphere, for example, CO2. The energy cannot be fully recovered again for useful work. All of these that comes out as the waste, you cannot convert it back to a lower energy, like a low entropy resource anymore, because it has been transformed from a low entropy resource into a high entropy waste. Right? So in the same way, when coal is burned in a power plant, we get electricity, but also waste heat, ash, and carbon dioxide emission. So what Reagan argued, that economic systems function in a similar way. Economics takes in low entropy resources such as fossil fuel, forest, fertile soil, fresh water, and transform them into products and services. But during this process, waste and pollutions are inevitably generated. For instance, mining iron ore produces steel for buildings, which is very, very important, and also for vehicles, but also leaves behind degraded landscapes, waste materials, and pollutions. Take the example of plastic. Plastic production creates useful products, but eventually much of it becomes dispersed plastic wastes in landfills and oceans. You can never convert it back to the raw material which allowed you to make the plastic. So the raw material was a low entropy, and now you have converted it into something during the production process, a byproduct which is of high entropy. Right? This is why the slide says that every economic activity uses energy, degrades matter, and produces waste. Even recycling cannot completely solve the problem because recycling itself requires additional energy and some material quality is always lost. For example, recycled paper fibers becomes weaker after repeated use, and recycling metal still requires energy inputs. The final implication here is very, very important, and it is this, actually these are every economic activity is actually connected to use of energy. It also needs to degrade matter. It also produces a waste, and all of these also have a limit. So a useful real-world example here is climate change itself. Economic growth powered largely by fossil fuel has increased production and consumption, but also generated massive amounts of high entropy waste in the form of greenhouse gas emission. So now we are actually struggling. How do we, make sense of this byproduct? How do we reduce it? how do we, ensure that it remains within the capacity of the atmosphere to absorb it? So if you look at this, burning of fossil fuel has led to a high entropy product, that is the greenhouse gas emission, which has also exhausted our sink. We don't have enough space to actually keep that waste which is generated as a high entropy waste. Neither we can convert it back to fossil fuel. Right? So now the question is, why does entropy, or why does throughput matter? So as mentioned in the earlier slides as well, that traditional or mainstream economics generally focuses on, things like prices, markets, monetary flows, GDP growth. For example, when economists study the automobile industry, they often analyze what? Production cost, profits, consumer demand, trade, employment, etc. Right? But what is missing here is that, these are all considered to be the economic success. Right? However, ecological economics argues that this is only a part of the larger picture, because money itself is not real resource. Money is an outcome because you have used that resource to generate money. Money can circulate endlessly in theory, but physical resources behind economic activity are finite. Every increase in production and consumption also requires greater extraction of energy and materials from nature, meaning greater throughput. For example, if GDP grows because more cars are produced and sold, this also means that more steel, aluminium, plastics, lithium, fossil fuel are being used. It means more energy consumption in factories, more transportation, eventually more emissions and waste. So ecological economics asks us to look beyond monetary transaction and examine underlying material and energy flow. And this is why this slide says ecological economics adds 4 important dimensions. That is also why economics and ecology gets connected. Material flows, energy flows, ecological limits, waste absorption capacity. So consider economic growth based on coal-powered industrialization. From a conventional perspective, this may appear beneficial because output and income would rise. But from an ecological economics lens, we would ask whether ecosystem can sustain the associated carbon emissions, air pollutions, and resource depletion in the long run. So the question becomes broader and larger because you are not just focusing on the economic efficiency, you are also focusing on how the inputs and the output, or the low entropy and the high entropy, is getting generated. How much of this low entropy is getting converted into useless high entropy product, which even if you recycle, you would need more energy. So the central box that you see on the slide captures this key distinction. So, we shouldn't just ask how efficiently our resources allocated, but how much throughput can ecosystem can actually sustain is also something which is very, very important. So in other words, are markets functioning efficiently? Are goods being produced at lower cost? Are resources being distributed optimally? These are the questions we ask in economics. But ecological economics is also asking you equally important questions like how much throughput can ecosystems sustain to do all of these things? So this means that there is an ecological limit to how much extraction, production, consumption, or waste generation the planet can handle without causing any irreversible environmental damage. So, we have a lot of examples. If I can give you the example of groundwater depletion, for example, in India, agricultural production may increase in the short term, contributing to economic growth, which it did. But excessive groundwater extraction eventually is reducing the long-term sustainability because, aquifers cannot recharge fast enough. So if we would have not just looked at the agricultural production, but also if we would have looked at the resource which is sustaining the agricultural production and ensured that groundwater replenishment also happens, connecting the economy with ecology, today probably we would have been in a much better situation. So the main message on this slide is that ecosystems must be evaluated economic systems must be evaluated not only in terms of market efficiency and growth, but also in terms of whether the scale of material and energy use remains within the ecological boundaries. And this is exactly what the ecological economics tries to question. So before I end, very quickly, the key takeaways from this paradigm shift, and this is the slide which summarizes all of these, is the first thing is that ecological economics emphasizes that there are, that economy, it's embedded in ecosystems, and because of which there are limits to economic growth, because you are within a finite ecosystem, and there is also limited capacity of the ecosystem to absorb waste. It also highlights the importance of scale, meaning that not only efficiency but also overall size of the economic activity relative to the ecological limits matter. The concepts of throughput and thermodynamics remind us that all economic activities require energy and material inputs, and inevitably it generates wastes and pollution. Therefore, sustainability requires managing resource use carefully and reducing pressure in ecosystems. Another important focus of ecological economics is again a bit different from neoclassical economics, is the long-term ecological resilience. So we are not just talking about a scale of operation of a firm or an individual in ecological economics. We are talking about the ability of the ecosystem to recover from stress and continue supporting human well-being. So for example, overexploitation of forests, groundwater, fisheries may definitely generate short-term economic gains, because we thought that we only need to worry about short-term, but all of these can weaken resilience and threaten future livelihoods, and that future is not very far. So that the key message of ecological economics is that sustainable development is not simply about increasing GDP or consumption. It is about improving human well-being while ensuring that economic activities remain within the ecological limits of the planet. So I'm going to stop here today, and I would suggest that do go through the reading that I have suggested. And I'm going to, so this was today more about the ecological limits and absorptive capacity. But in the next class, we are going to deal a little bit more on what are these finite resources that we are talking about. So thank you very much.